All right, so welcome everyone, and let's welcome our guest, Dr. João Martina from Brazil. We go back a long time. Yeah, you can applaud. So we met 207 in Markt Oberdorf, which is this tiny little place on in the Alps, or right at the border of the Alps in the south of Germany. It was my first year as a PhD student, and I was at that summer school as one of the assistants of the professor who was organizing the whole thing. And Jean was an attendant at the time, and yeah, thanks to big social media, we've loosely stayed in touch since then. And he reached out a while back saying, "Hey, I'm gonna tour California. can I put you on my list?" And I'm like, "Of course you can. Please come over and give a guest talk here and check out our campus." And so he's here this evening. He does a lot of interesting research in computer security and the Internet of Things and a bunch of other things. So I'm going to pass it on to you because you're the expert on the topic.
All right, thanks, Bridget. Yeah, guys, I would like, first of all, to thank you all for being here. And what I would like to talk today and to present to you is part of a big project that we are running there in Brazil at my university. Then I'll bring it into context later, show you where actually this is happening, because it's difficult. Brazil it's big and it's far away, so it's difficult for you to have an idea where it's happening. But the idea is that we're having a project there that we call Smart Campus. And this Smart Campus is generating a lot of data that we are collecting from things that people do on the campus on a daily basis. And either if you go when you go to park your car, or when you go to the restaurant, either if you are attending lectures, or we record the weather and loads of things, and we put all this data inside a big database that we have in there. And what we have in there now is this data that is being collected, and we want to make it available for university research. So we want to give this data to people in social science, in engineering, so that they can use this data to produce more knowledge. And one of the big issues that we have is that this data that we are collecting, they are being collected by the university, but they actually belong to people. So we have to keep in mind that we cannot give away this data without putting a layer of privacy in it and respecting people's privacy on using this data. Okay? So just to put you into context, where we are based, this is Brazil. This is this map here. We're based in Florianópolis, that is a small island in the South Atlantic. And it's an island, sort of speaking, because we're just 1.5 kilometers, like a mile from mainland. So we have plenty of bridges, and basically it's part of the continent, so it's not an isolated island. And we're best known in there because the island itself has more than 40 beaches, and it's a very big summer destination in Brazil. But while we are not surfing or enjoying the sunshine, we are working. And to bring you a bit of context to you about what I will talk later, I would like first to talk about the Internet of Things. And when you hear about Internet of Things, most people think about devices, but you see that devices are inherently tied to people. So we don't like to tell people about the Internet of Things. We would like to talk about the Internet of Things and people, because people are inherently tied to their things. So what we see today is that more and more things are interconnected. So from your fridge to your car to your smartwatch and so on, everything collects data and feeds this data to the cloud to be used somehow. Okay, things that are usually related to people. There is no thing anywhere that doesn't belong to anyone. Either it belongs to a person or to an entity, and the data collected from there will inherently be tied to that entity, either a person or a university. And those things generate a lot of data. For you to have an idea, just our weather monitor system within the campus generates like a gig of data a day, like measuring rain, incidence of solar radiation, wind direction, and so on. We have probably 10 different spots, so we know when it's raining in one side of the campus and when it's not raining, when there is sunshine, when it's cloudy, and so on. And as I said, this data is related to people. And what happens, and that's the most scary thing, is that this data usually is not owned in the sense that they are cared for by the people. The data is related to people, but it is on someone else's data store. And that's one of the problems. But still, we need to keep in mind that there is this connection between the thing and the person. Use of this data, whenever I would like to use that, I need to take into account that it's not a thing that, yes, there is a thing that generates the data, but the data was not generated by the thing, but it was only collected by that thing. It was probably generated by interactions between people and between the things within the real world. And the use of this data needs to take into account the data owner, that is the person that actually generated the data, to know if it will take into account the privacy or not of that person, what the person believes should be shared or not. And the question that we put ourselves on this setting of the Internet of Things and People is, how can we use this data without breaking people's right to privacy? So I have a lot of data that can be really, really useful for planning purposes, for security, for health issues, and so on. But I need to have a way to use this data without letting anyone be identified or anyone be picked or harassed, and so on. Coupled with that, we have the concept of big data knowledge extraction, or big data and analytics. So we know that data is no information. Data is just a bulk of things, of records of what happened. And to make that into information, we need to apply some technique that will bring information and later on knowledge regarding that data. And as you know, we are said to be in the information age. It means that we have a lot of means to transform data into information. And now with the advent of cloud computing, what happens is that we collect this data, we offset it to somewhere, and we have almost unlimited processing power to extract information out of this data. So we also have omnipresent data collection. Anything that you have can and may and probably is collecting data about the environment and about yourself. Our phones are collecting, our wristbands, our cars when being driven around the roads, and so on. All that generate these data. We have reasonably powerful machine learning algorithms these days. So out of that data, we can infer much more things than the data itself. And sometimes machine learning algorithms can be better than ourselves into extracting clusters of things that we never imagined that could be put together. And also we can learn more about people than actually themselves know about what they want. So that's basically the magic that Google and Facebook do to make money. They try to give you offers on what you actually will want, even if you don't know that you want that at that very moment. And also we can, and that's the big problem with big data and analytics, is that we can uniquely identify people by patterns. And that's a problem, because if we collect data, and this data is somehow related to people, And even though we apply some technique to, like we detach the identity of someone, if we use such big data and analytics and machine learning techniques, we can re-identify that data in a very easy way. There is a classic case on literature that was, I think, here in the US, in Boston, that they released some medical data, and then they just got the electoral lists, and they re-identified everybody with that they had detached the identification data, and then basically it was possible to cross each voter with their health conditions, and that's pretty bad. And also, as I said, we can predict behavior, and that's sort of scary because of our inner sense that we tend to think that we are unpredictable. About the smart campus. I'm talking about the smart campus, but you can read it as a smart city, smart buildings, or anything that they could smart. That means that they would be collecting data and using that data in that environment to make the environment either more efficient or more environmentally friendly, sustainable, and so on. So what we do at our campus there in Florianopolis is that we collect a lot of data about what people do in the campus. And we put all that data into a single data store, and we use that data later on to do research. So basically we know when you enter the parking lot, because everybody is issued with a university card, and then they need to pass it to have access to the parking lot. We know when you had your coffee at university, because coffee is free, but you need to identify yourself. We know your lunch preferences, because we have a university restaurant, and we know when people are eating there or not, because they need to touch their university card for that. We know where you go around the campus, because you have a mobile phone that's probably connected to EduRoam, and then whenever you move, you connect to another access point, and we know where the access point is, so we can tell how you move around the campus. We can tell the temperature you like in your office, because we have also sensors on the temperature for some rooms, and then we know who is in each room, so we can tell that sort of things. We can tell your class attendance, even though we don't actually need to pass a list or anything, because you know actually where you are. We know the books you borrow from the library, the amount of lighting you like inside your working space, because we have some sensors for that. We know the time you spend in each place, we know the weather, we know also which bus you take to get into the campus, which bus you take to go out of the campus. And all this data is being collected 24 hours a day and 360 something days a year. And the thing is, we collect this data because it's inherent of the process. We need to, for example, we need to grant access to EduRoam only to people that belong to the university. There is a log for that. Instead of just throwing that away, at least in Brazil there is a law that requires us to keep that log for 5 years. So instead of just keeping that log for 5 years, we keep that log and then we cross it with other things to gather information about what's going on. All the other things, for example, to control the parking lot. The university is on a very central place in the city. So if you don't control parking just for students, all the city will park inside the university because it's free parking. Then lunch preferences. We give subsidized food. Basically, a lunch or a meal costs less than 40 cents for the student. So the students sometimes, they work somewhere else within the city. They come to university only to have lunch because it's really cheap. Like if you have lunch outside, it will cost you $10. If you have lunch inside university, it's 50 cents. So it's sometimes it's worth to paying the bus to go to the university to have lunch and then back to your work. And all these things, like we have a smart building where we try to minimize energy usage. And And also with that we collect those preferences from people, because we would like it to be comfortable to the person at the same time as we wanted the building to save the most energy possible. So it's a bit scary saying that a university collects all that, but this data collection is inherent of the business of the university. So what we are doing here differently is that we are centralizing it all in one place, and we are creating an interface for people to research over that data, to understand how things happen inside a campus. So just for you to have an idea what we have in terms of infrastructure, we have some buildings. This is, the university has two main sites within the island. One is in the center of the island, the other is in the north, and it's like 20 miles the distance. And this is part of our science park. It's all, and this is called the solar building, because the whole building is built on solar panels, and it generates 5 times more electricity than it uses. And what we're doing here, we monitor basically air conditioning, windows, lighting, everything, to make it consume even less than it already consumes. And here we have another feature, that is, we have a solar-powered bus, that we have 3 of these buses, that they interconnect the main campus and the science park. I think I have a picture of the bus itself here. Yeah, that's one of the buses. And it runs 100% on solar energy. And we also use the same technology for monitoring everything inside the bus. We know, we can infer traffic conditions within this link between the main campus and the science park, because we can monitor how many times the driver pressed the brake. And all this information goes to the same data store where we have the other things. And then we have these weather stations that are all interconnected in the campus, and they produce reliable weather data, and within the different sectors, because the campus is quite big. The campus is, I think I have a slide later, it's 5,000 acres in size. So it's a reasonably big campus, and sometimes it rains in one spot and it doesn't rain in another. Sometimes it has like 5 degrees temperature difference between one spot and another. And then the thing is, a lot of good things can be done with that data that is collected by the university within this smart campus setting. One thing that can be done that we are started doing is we can direct you to the best parking spot depending on what you're gonna do in the university. So if you're attending classes in one building, we try to direct you towards the closest parking space, that parking lot that has a space for you to park. We can tell the restaurants what menus are more popular and serve them more frequently. That's another thing that we have been doing since a month ago. We can save energy a lot on this scheme. Like with these new buildings and these IoT interconnected buildings that we are putting in place in there, university is saving around 25% on the electricity bill every month. And we still have probably 50% of the buildings to be put into this scheme. So it will be even more than that. We can help the university with planning of spaces for events. So as we can detect movement of people, and we can monitor that, we can help the university to plan better where to put, like if we have a conference that is being held in there, we can tell which are the best conference rooms for the visitors, where to put them in terms of lodging